discussed the division algorithm. In this video, we'll discuss remainder classes. Now, the division algorithm tells us that there are only b possible remainders when dividing by b. If we fix the divisor, we can group integers by the remainder. Each group is called a remainder class modulo b, or sometimes called the residue class. Hey everyone, real quick, I just want to mention that this video is a part of a whole course that I made. You can find a link to this entire course in the description below, and make sure to click on that subscribe button. All right, let's do an example together. Describe the remainder classes modulo 5. We want to classify numbers by what their remainder would be when divided by 5. From the division algorithm, we know there will be exactly 5 remainder classes because there are only 5 choices for what r could be. If you remember, according to the division algorithm, r is somewhere between 0 and 5, not including 5. Let's first consider the case where r equals 0. Here, we are looking for all the numbers divisible by 5, since according to the division algorithm, this means that a equals 5 times the quotient plus a remainder of 0. In other words, the multiples of 5. We get an infinite set. What are the multiples of 5? Well, there's negative 15, negative 10, negative 5, 0, 5, 10, 15, and so on. And so on in both directions too. Notice we also include negative integers though. That's really important because we're looking at integers with this. Next, let's consider r equals 1. So in this case, we're looking at all the integers, which gives a remainder of 1. According to the division algorithm, the number has a remainder of 1 when using the division algorithm. So which integers, when divided by 5, have a remainder of 1? Well, let's build our set here. Certainly 1 does, as does 6 and 11. What about the negatives? Here we must be careful. Negative 6 does not have a remainder 1. We can write negative 6 as negative 2 times 5 plus 4, meaning that the remainder in this case would be 4. Or maybe we have negative 6 equals negative 1 times 5 minus 1. But only one of those instances is correct, is a correct instance of the division algorithm. So negative 6 is not in this remainder class. So let's write them all out. Technically, the next one is negative 4. If you notice, they're all spaced 5 apart. And so on. So for r equals 1, we get that negative 4 is in there, negative 9, and so on. So the remainder class is negative 14, negative 9, 4, 1, 6, 11, 16, and so on in both directions. There are 3 more to go. The remainder classes for 2, 3, and 4 are as follows. I'm going to write them all out. And you can probably expect to see, you could probably guess what these are going to look like now that you see the pattern. So in this case, it's going to be negative 13, negative 8, negative 3, 2, 7, 12, 17, and so on. For r equals 3 and 4, we have negative 12, negative 7, negative 2, 3, 8, 13, 18, and so on. And last but not least, r equals 4. We have -11, -6, -1, 4, 9, 14, 19, and so on. Note that in the example from earlier, every integer is in exactly one remainder class. We did that example in a previous lecture. The technical way to say this is that the remainder classes modulo b form a partition of the integers. The most important fact about partitions is that it is possible to define an equivalence relation from a partition. This is a relationship between pairs of numbers which acts in all the important ways like equals. At least the equals relationship. Anyways, thanks everyone, and I'll see you in the next video.